Okay, and then for this one, for the neutron, the relative mass is 1. Relative mass of neutron is 1. And then the relative charge of proton, the proton is positive, relative charge. This one is positive 1. And then the relative charge of electron is negative 1. And then the neutron, the charge is 0. It doesn't carry any charges. Now, mass number. Mass number, define the terms mass number and atomic number of an atom. Mass number is the number of protons plus number of neutrons. And then atomic number is number of protons. Okay, so mass number or called as mass number is also called as this one, nucleon number. Okay, so mass number is the same as nucleon number, is the proton plus neutron. Okay, and then next question here, give the symbol including the mass number of an atom which has 3 fewer neutrons and 2 fewer protons than nitrogen. And then the element here is must be let me ask to some Billy. Hello, Billy. Hello, Billy. Are you there, Billy?
Yes, sir. Yes,
Yeah.
sir.
Okay. Can you tell an atom that has 3 fewer neutrons and 2 fewer protons than nitrogen?
Wait, sir.
Yeah, you can see in the periodic table an
Yeah.
atom that has 3 fewer neutrons and 2 fewer protons than nitrogen.
Mm,
What is it?
wait, sir. Googling, sir.
Yeah. Oh, still googling. Okay. It is 2 fewer protons, uh, 2 fewer protons and 3 fewer neutrons. This one, Billy. Neutron, proton, 2 less proton. So the proton is 5. And then, what is the neutron here, Billy? How many
14.
neutrons? How many neutrons?
14.
No, the nucleon is 14. The mass number is 14, but the neutron is not 14. How to
7,
find
7.
neutron?
7, 7.
7. So the neutron is 7. If 3 less, meaning the neutron must be
4.
yeah
4.
must be 4. Yeah, the neutron must be 4. What is the nucleon of this atom? This is an atom. What is the nucleon? Nucleon is proton plus neutron. The
Oh yes, yes.
neutron, the neutron of this element, of this atom is 4.
Mm-mm.
So proton plus neutron become nucleon. What is the nucleon here? How many? It is 9.
Oh yes, yes.
What is the element? What is the element that has the this one 9, the mass number 9, and then the proton is 5? What is the element?
I don't remember, sir.
Yeah,
I
yeah,
don't remember.
yeah. Of course, I also do not remember. If I do not see the periodic table, I also do not remember.
Oh, boron, sir.
Yes, correct. So X is boron.
Yeah, yeah, boron.
Yeah. So the X is boron.
Oh yes, yes.
So boron is the atom that has 3 fewer neutrons and 2 fewer protons than nitrogen.
Oh yes.
Okay. Now D, in terms of the number of their fundamental particles, what do two isotopes of an element have in common and how do they differ? This is discussing about isotopes. Let me ask. Let me ask to Kevin P. Hello, Kevin. Kevin P. Kevin Prastio.
Yes, teacher.
Yeah. What do two isotopes have in common?
Same number of
Yes. Same
same
number.
number of neutron.
No.
Wait.
It is
Uh,
number of proton.
apa? Oh yeah, same number of proton.
And then what do they have in? What do they have difference?
Different number of neutron.
Exactly. So the neutron different. So the difference is the neutrons. The same
Yes.
is the proton. Now define the relative atomic mass. Define the term relative atomic mass of an element. It is the mean mass of an atom compared to compared to uh, 1 by 12 compared to uh, 1 by 12, okay, compared compared to 1 by 12 of carbon 12. So that is the meaning of relative atomic mass. Okay, now let's proceed to the next question. Let's proceed to the next question. This one. When a pure gaseous sample of element X is introduced into uh, this one, introduced into a mass spectrometer, 4 mononuclear singly charged ions are detected, as shown in the spectrum below. So there is a mass of 84, 82, 83, 84, 85, and 86. 85 is empty, so directly jump to 86. And there is a relative abundance. Use the data from the spectrum above to calculate the relative atomic mass. Yesterday we learned already how to calculate relative atomic mass. Now for today, let me ask to Eiffel. Hello, Eiffel. Are you there?
Yes.
Yeah, okay. Can you help us to calculate the relative atomic mass of an atom X with this abundance and also relative and also the isotopic mass? Yes?
I don't know, teacher.
Ah, okay. Let me ask to Celine. Celine, hello, Celine.
Hello. Yes, teacher.
Can you help us to calculate this one, the relative atomic mass of an element X?
Um, I also don't know.
How come you do not know? It is it is not too difficult. Okay. Okay, so this one is 1 times 82 bracket plus 1 times 83 bracket plus 6 times 84 bracket and then plus open bracket 2 times 86 close bracket. Now this one we get the total. Total is 841. And then this one should be divided. Oh, wait. This one, let's see, 80, 82. So 6 times 84, 6 times 84, 6 times 84, and then plus 2 plus 172 plus 83 plus 82 plus 82. Okay, 84 times 6 plus 86 plus 86 plus 83 plus 82. Oh yeah, 841. And then this 841, it should be divided by 10. Why is it 10? Because based on this one, based on the relative abundance, this one percent, this is 1 plus 1, 2 plus 6, 8. 8 plus 2, 10. So the relative atomic mass of the element X is 84.1. Now let me ask to Hayato. Hello Hayato. Are you there, Hayato?
Yes, sir.
Yeah. Can you open your periodic table and tell us what is the identity of element X that has the atomic mass of 84? Please find on the periodic table what is the element that has the atomic mass of 84.
Hello.
Hello? Yes, Hayato?
KR.
Kr. What is the name of the element? The symbol is Kr. The symbol of the atom is Kr.
Krypton.
Yes, correct. So it is a krypton. Correct. It's correct, Hayato. And then now let's move to number 2. Number 2 here. Number 2 here is written. Why is mass spectrometer incapable is not able of distinguishing between ions 14 and plus and 14 and 2 plus? It is because both of them have the same mass. So both ions have the same mass because it is based on the mass spectrometer. Mass spectrometer is working based on the mass. If two ions with the same mass spectrometer cannot identify. Now B, give a reason why it is unlikely that F negative ion would reach the detector in mass spectrometer. Unlikely means it's not happening because F negative ion is not accelerated. Okay, because F ion is not accelerated. Okay, now this one. Next, hydrocarbon. A hydrocarbon was introduced into mass spectrometer. This one, hydrocarbon is a molecule. Okay, hydrocarbon is a molecule consisting of hydrogen and oxygen. So this one is containing carbon and hydrogen. And then in order to find, we are not able to find just like the relative molar mass, relative atomic mass of an element. Okay, so here, since hydrocarbon is a molecule, the relative molecular mass is based on the highest MZ ratio. So the molecular mass of the hydrocarbon hydrocarbon is 58. Okay, so the highest, so the molecular mass of hydrocarbon is 58. Okay, now let's continue to this one. Now, this one using arrows, arrow up and down. Up and down means the electron spinning direction. One is clockwise and the other one is anti-clockwise. In order to write this one, we have to use the arrow. So wait, I have to use the arrow. So we have to do annotation again. So arrow like this one. So 1s, it should be up. Oh, sorry. Okay, it should be like this. 1 and then 2. Also with this one, this one has to be why doesn't move? 1 and then there is 2. And then for carbon, let me ask to Janice. Janice? Hello, Janice. Are you there?
Yes, teacher.
Yeah. How many electrons are there in an atom of carbon? Can you open your periodic table? How many electrons are there in an atom?
6.
6, correct. The subshell electronic configuration is 1s2, 2s2, and then 2p2. Because it is 2p2, right? According to the Pauli exclusion and Aufbau principles, we have to fill in all the orbitals first. We are not supposed to make one orbital full, then the rest of the orbitals should be emptied. That is not the rule. Okay, so the rule is all orbitals must be filled with an electron. All orbitals must be filled with electrons that have the same spinning direction. Look at this one. This one, it has one type of spinning direction, and the other P, so this one is here Px. This one here is P, oh, sorry. This one here is Py, and then here is Pz. Okay, Px, Py, Pz. So the electrons must be put into the orbitals with the same spinning directions. And then after all the orbitals have been filled with the electrons of the same spinning direction, then we put the other electrons with the different spinning direction, with the opposite. So here is like this one. So one orbital with up and the other orbital also with up. Okay. Now, in terms of sub-level, give the electronic configuration of the carbon ion C2+. So in C2+, we have to write like this: 1s2. It will so the electron that will lost from the outermost first. The outermost of this one is from 2p orbitals. So this one is 2s. So this is the configuration of subshell electronic configuration of C2 plus. And then D, give the complete electronic configuration of krypton in terms of S, P, and D sublevels. Okay. Now, before I continue, let me ask to this one. Let me ask Nia. Hello, Nia.
Yes.
Yeah, Nia. I would like to ask from your periodic table, how many electrons are there in krypton?
Krypton.
Yes. How many electrons are there in krypton?
Mm,
In what group is krypton in the periodic table?
uh, um, mm, 36 electrons.
30,
6 electrons. 36.
36 electron.
This
That's
is
correct. No.
uh,
36 or 26 or
yeah,
46?
36.
36. Okay. Uh, from yesterday, Kenya.
Mm,
Please tell the subshell start from 1s2 until
mm,
36. 1s2,
1s2.
yes.
Um,
Then 2,
um, 2s2.
yes. 2s2, and then
2p6.
2p6. After that,
3s2.
yes. After that,
3p6.
yes. Please continue.
Mm, 4s2.
Yes. Then,
3p10.
yeah.
4p6.
Yes. After that,
Mm, 5s2.
yeah. After that, after 5s2,
Uh, e, yeah, that.
yeah. No, it is not until 5s2. Remember, the number of electron is only 36.
Yes.
Yeah, so should be the ending is
The
the ending is what is the ending?
uh, the ending 5s2.
Okay, please count, Nia, from 1s2 until 5s2. How many electrons are there?
36.
Are you sure? You mentioned 1s2, 2s2, 2p6. From 1s2, 2s2, and then 2p6, how many electrons are there already
Um,
from here?
38.
Yeah, until
So
5s2 is 38, right?
yeah, so it's 4p6 until and
So the ending is
46.
exactly.
Yes.
Yesterday I told to the class that if ending with P6, it means this element must be an noble gas element. Must be a noble gas element. Now, can you tell me, Nia?
Yes.
Can you tell me what is the period of krypton in the periodic table? In which period?
Group group group
No, it's
0
a group period.
or period.
Yeah.
Period. Wait.
Do you know how to read the period in the periodic
Yes.
table?
4.
Exactly. So this one is called the period. Okay, the quantum number tells us the period of the element in the periodic table. The P here, the P tells us what group of element is the atom located in the periodic table. Is it group of metal, group of non-metal, or group of transition metals? If P say if ending with p orbital, it means it is a non-metal. Okay, and then it is a non-metal. If it is in S, if ending with S like this, Nia, ending with S, this element must be belong to a metal.
Yes.
Group 1 and group 2. Okay. If
Yes.
ending with D, it must be a transition metal group. Now, please please help us, Nia, because you're not you should not be afraid. You have to study if you want to gain more knowledge. This one, E, Nia. Look at
Yes.
copper. Can you locate copper in the periodic table?
Yes.
Yeah, copper is in metal or non-metal or transition metal.
Mm, wait.
Can you find copper?
Transition.
Yes. So if transition metal, then the last orbital it should be in the P or D.
T.
D. Now
Yes.
now uh, can you tell us, Nia, how many electrons are there in copper?
29.
29, exactly. So can you help us to continue this one? The what is the subshell configuration? This one already here is 10, here is 10, and then here is 8.
Yes.
Yeah. So can you help us to continue?
For S2.
Yes. Here is for S2,
3 T9.
3,
T9.
3, 3D,
T9.
9.
9.
Yeah. And then,
Mm,
oh, oh, you write here for S,
for S2.
S2, and then 3D9.
3 T9.
Yeah. This one, this configuration is considered to be incorrect. Why? Based on the energy level, is correct. After 3p, 4s, 3d. But based on the stability of the electron, it is incorrect. Now, please see here, it is in 3p, 3p6, 4s2, 3d9. According to the quantum number 343, between 4 and 3, which one is in the outer shell? 4 or 3? Nia?
Oh,
It is
4.
4 in the outer. So if
Yes.
it is in the outer, so this is instead of 2, this one should become 1. So this one 1 as 4 as 1, and then here is not 9, but this one is 10 based on the stability. Okay.
Yes.
Okay, and then for the electron here, subshell configuration of the copper 2 plus, based on the ion, this one, the stability, this one, it will lose an electron from the outermost shell. What is the outermost shell is for S1. So in here will be 3D. So because it lost an electron, so it become 3D9. So for S1 and 1 electron from the d orbital lost. Okay, understand, Nia?
Yes.
Okay, that's good. Now, before the class is over, I would like to take the attendance of 11p. Okay, I would like to take the attendance of 11p. Wait, let me open the attendance of 11p. Okay, attendance of 11p. In here, I can see that. Oh, hello Atta. Hello Atta, are you there? Atta. So Alicia is absent. Alberto is absent. Andrew is absent. And then Carlton. I do not see Carlton. Carlton is absent. And then Janice, Kayla, Kevin, Mario. Mario is here. Mario is here. Matthew Dharmaputra is Matthew Dharmaputra is MDP.
Sure.
Yeah, so MDP is Matthew Dharmaputra. Okay, Matthew is here, and Max is here. Natania here. Rizky is absent. So Rizky, Saka, Sarah, and Valentino are absent. Okay, so the rest, this one, page 5, the last page is homework. You should do at home. So this number 4, only one number. I have put the homework on Google Classroom. Okay, please do it and submit it. Okay, students. Okay, thank you. Good afternoon. Then we will talk again on Monday. You may leave the discussion room.
Thank you, teacher.
Teacher.
Yes.